Good afternoon. This is the notes for Wednesday, October the 18th. Today our learning target was I can solve polynomial and rational inequalities. I can solve polynomial and rational inequalities. We're on page 51 of your notebook, page 51. I'm not doing all 9 examples. I'm pick and choose some. This right here might confuse you, so I'm going to explain it as we go, okay? So I'm going to start on number 1. Number 1. And we have x minus 1, times x plus 3 less than 0. Okay, so let's talk about this for a minute. If I was to multiply this out or count the number x, and there's 2, so that means this is a quadratic inequality. And you solve these different from linear, what you've done in Algebra 1 and Algebra 2. Alright, so let's come up with some steps to solving polynomial inequalities. Okay. First thing has to be set to 0. And when I mean 0, I mean like this. This to 0, just like if it was a quadratic equation. 2 must be factor. Factor it. It's already in factor form. That's great. 3, find zeros. What makes it equal to 0? Alright, so we factor it. Okay, find the zeros. It's x equals 1 and x equals negative 3. Let's make a number line. Okay, what is this question asking you? It is asking you to find the values of x that make this inequality less than 0. For what values of x would you get a y value that is less than 0? So in order to do this, we're going to graph this. So we found the zeros and made a number line. And make number line. Okay? Now, I'm going to graph this on my calculator. Graph. It should cross at negative 3 and 1, which it does, because those are your zeros. Now, before we start looking at our graph, let's think about it a minute. Since this is less than 0, it's not less than or equal to. It's not less than or equal to. Would you include these numbers in your answer? No. So that's why I'm going to put an open dot. That means it's not included on the 2 numbers right there. Now, guys, what we're going to do is look at our graph. We're going to look. There's 3 intervals that could be our answer. The region over here, region here, region here. Well, we're going to look at our graph. If you notice from here, from negative infinity to negative 3, from negative infinity to negative 3, our y values are above the line. That means our y values will be positive. So I'm going to put a plus right there for positive. Now, from negative 3 to 1, the line goes below the x-axis. That means it is negative values. The y values are negative. And then from 1 on, the function comes above the x-axis. The y values are positive again. Now, for this particular problem, we want it less than 0. So we're going with this region right here because this is negative. So my answer in interval notation will be negative 3, 1 is my answer. Alright, let's look at number 2. Alright. Number 2 is x squared minus 3x squared equal to 0. So step 1, make sure it is quadratic, so it needs to be set to 0. We need to factor it. I'm going to do GCF, take an x out, that leaves an x minus 3. Find my zeros is x equals 0 and x equals 3. Make a number line. I'm going to graph it. That's why it's so important to have a graphing calculator. Should cross at 0 and 3, it does. Now, let's look at our 3 intervals. Before we do that, let's see. Would we include 0 and 3 because it says greater than or equal to? We would. That would be a closed dot. Include it. Now, we want the values that make this positive because it's greater than or equal to 0. If you look from negative infinity to 0, the line is above. That means you get positive y values. From 0 to 3, it dips below, so the y values are negative. And then this is positive. We want it greater than 0. That means we want the positive values. So it will be from negative infinity to 0, bracket, closed dot, union, 3 to infinity. Would be my answer. All those numbers in those intervals would be my solution. So let's go to number 4. 2x squared plus 3x less than or equal to 5. It's got to be set equal to 0, so I'm going to bring this over. 2x squared plus 3x minus 5 less than or equal to 0. I'm just going to come over here and factor it. That is bust them up. It's got to multiply to give you 10, negative 10, add to give you 3. That's going to be 5 and negative 2. So I got 2x squared plus 5x minus 2x minus 5. Take an x out, that leaves a 2x plus 5. Take a negative 1 out, that leaves a 2x plus 5. Get x minus 1, 2x plus 5. X equals 1, and x equals negative 5 halves. So those are my zeros. So I'm going to make the number line. Negative 5 halves is negative 2.5 and 1. Now I'm going to graph this one because you graph the thing is towards 0. So I'm going to graph that. 2x squared plus 3x minus 5. It should cross at negative 2.5, which it does, and 1. Now, what is going on here? From negative infinity to negative 2.5 is above the line. That is positive. From negative 5 halves to 1, from negative 5 halves to 1, it dips below the line. That is negative. From 1 on, my y values are positive, so that's going to give you positive values over here. Now the problem is we want the values less than or equal to 0, so that means negative numbers. So it's going to be this interval right here. Let's talk. Will we include them? It says less than or equal to 0. These two numbers make it 0, so yes, we would include those. So it's negative 5 halves to 1 is my answer. The interval negative 5 halves to 1. Okay, let's look at number 7. This is going to be our last polynomial. We're going to do a cubic here, number 7. X cubed plus 2x squared minus 15x less than 0. First thing I'm going to do is try to factor. I can take an x out. That leaves x squared plus 2x minus 15. Easy. X plus 5, x minus 3. My zeros are 0, negative 5, and 3. When I do this, I'm making a sign chart because I'm worried about what the signs are. So I'm going to graph the original. Y equals x cubed plus 2x squared minus 15x. It should cross at 0, negative 5, and 3. Let's graph it. Very good, it does. Now, looking at this, from negative infinity to negative 5 is coming up, so it's below the line, so it's negative. From negative 5 to 0, it's above, that is positive values. From 0 to 3, it's below, negative, and then positive. Okay? Now, it says less than 0. These make it equal to 0, so those will all be open dots there. Now we want less than 0, so it's going to be from negative infinity to negative 5. Union, jump over this, 0 to 3. Now we're going to move into rational inequalities. Rational inequalities. Okay? I'm going to write some steps. Steps to rational inequalities. Step 1. Find zeros. Well, so we set equal to 0. I won't give you any of these on these particular times. It's not, but so we set equal to 0. Set to 0. 2. Find zeros of denominator and numerator. Okay. Make number line. And then 4, plug in. You can't use your calculator on this. Plug in numbers. So yeah, you actually have to plug in. Alright, so on this first one, find the zeros of the numerator and denominator. Denominator is easy. X equals 5. Up here, set that equals 0, x will give you 2. So I got 3 intervals. Now, before we go on to determine if it's positive or negative, we need to know what these two numbers do here. If I was to take 2 into this, 3 times 2 is 6. 6 minus 6 is 0. Zeros in the numerator. When 0 is divided by something, it gives you 0. This says less than 0, so I could not include that because that would make that equal to 0. If I plug 5 in this, 5 minus 5 will give 0 in the denominator. That's undefined, so they're both going to be open here. Alright, now, like I said, you can't graph this. You're going to plug in numbers from this interval. I'm going to pick a number that's in the interval left of 2, which is 0. If I plug 0 here, I will get negative 6. If I plug 0 here, I'll get negative 5. Negative 6 divided by negative 5, a negative divided by negative equals a positive. That is what I'm concerned with. I'm not concerned with the actual numeral value. I'm concerned with the sign. I'm making a sign chart right here. Now, I'm going to plug in 3. 3 times 3 is 9. 9 minus 6 gives me a positive number. I plug in here. 3 minus 5 gives me a negative. So a positive divided by negative is a negative value. I plug in 10, because it's over here somewhere. 3 times 10, that gives me a positive, and a positive divided by positive is a positive. I want values of x that make it less than 0. It would be in this interval. 2 to 5 would be my answer. 2 to 5. Parentheses because they're both open. Number 9. X plus 5 over x plus 2 less than or equal to 0. Okay, you got to find the zeros of denominator and numerator. This is the only time we have found zeros of numerator. So that's going to give me negative 5 for the top and negative 2 for the bottom. Plug number. If I plug negative 10, negative 10 plus 5 will give me a negative. Negative 10 plus 2, negative divided by negative is a positive. What would negative 5 do itself? Negative 5 plus 5 will give me 0 on top. It says less than or equal to, so I could include that. I pick a number, -3. -3 plus 5 is a positive. -3 plus 2 is a negative. Positive divided by negative will give me a negative. -2 plugged in will give me 0 in the denominator, which is undefined. And then I plug in 0, that will give me 5/2, which is positive. I want it less than or equal to 0, so I'm looking at this region here. I can include that. So it's -5 to 2, parentheses, is my answer. Your homework for this is page 53, numbers 7, 8, 10, 11, 13, 14, 16, and 17. 7, 8, 10, 11, 13, 14, 15. 7, 8, 10, 11, 13, 14, 16, 17. See you tomorrow.